Have you ever thought about what would happen if Earth suddenly lost its magnetic field? It may sound crazy, but this could lead to some serious problems for life as we know it.
Earth's magnetic field acts as a shield against solar and cosmic radiation. If this shield were to suddenly disappear, the consequences would be profound and far-reaching. Initially, we would see an increase in solar radiation reaching the surface of the planet. This would particularly affect power grids and communication networks, potentially causing widespread blackouts and satellite malfunctions. The absence of a magnetic field would also lead to an increase in radiation exposure for all life forms, leading to a higher incidence of cancers and other health issues. Moreover, the atmosphere itself would start to erode over time. This erosion process would be accelerated by solar winds, which could strip away the layers of our atmosphere, much like what has happened to Mars. Over thousands or millions of years, this could lead to significant changes in our climate and potentially render Earth uninhabitable. In essence, losing the magnetic field would transform Earth from a thriving, life-supporting planet to one that could more closely resemble the harsh, barren environment of Mars.
But that's not all. The magnetic field also helps to generate the beautiful aurora displays we see in the polar regions. It's responsible for the Earth's geological activity, like the movement of tectonic plates, and even guides migratory animals during their journeys. Dr. Lisa Tauxe, geophysicist at Scripps Institution of Oceanography, discusses some scenarios that could cause a loss of the Earth's magnetic field.
The Earth's magnetic field is generated by the motion of molten iron and nickel in the outer core. This motion creates a dynamo effect, producing the magnetic field. If the core were to cool significantly, or if the convection currents driving this motion were disrupted, it could weaken or even collapse the magnetic field. Several scenarios could potentially cause this dramatic change in Earth's rotation rate. A significant alteration in Earth's rotation could disrupt the flow of molten metal in the outer core, affecting the dynamo process. Major impact event. A large asteroid or comet impact could deliver enough energy to disrupt the core's dynamics, potentially altering the magnetic field. Significant changes in core composition. Geological processes, such as large-scale volcanic activity or shifts in tectonic plates, could change the composition of the core, affecting the magnetic field generation. While these scenarios are speculative and would require extraordinary events, they highlight the delicate balance that maintains Earth's magnetic field.
So, what makes the magnetic field so vital to our existence? Well, it's not just a pretty phenomenon. It's an essential component of our planet's defense system. Without it, we'd be left vulnerable to the harsh conditions of space. The potential consequences of losing the magnetic field are dire. One of the most immediate effects would be a massive increase in radiation exposure. Solar flares and coronal mass ejections would bombard the Earth's surface, damaging our power grids, communication systems, and electronic devices. Imagine waking up one morning to find that your phone, computer, and even the lights in your home no longer work. Prolonged exposure to this radiation would also have devastating effects on living organisms. It would increase the risk of cancer, damage our DNA, and even alter the behavior of certain species. The impact on the food chain would be catastrophic, as mutations and diseases spread rapidly throughout ecosystems. The effects wouldn't stop there. The loss of the magnetic field would also disrupt global satellite communications, aviation, and navigation systems. Ships and planes would struggle to navigate, and our ability to predict weather patterns would be severely compromised. Dr. Sarah Jones, space weather scientist at NASA, explains,
"The loss of Earth's magnetic field would have catastrophic effects on global satellite communications, aviation, and navigation systems. Without the magnetic field, satellites would be bombarded by high-energy particles from the sun, leading to frequent malfunctions and potential loss of critical communication and GPS satellites. This would disrupt everything from weather forecasting to global positioning systems, severely impacting aviation safety and efficiency. In aviation, the absence of a magnetic field would render traditional compass-based navigation systems useless, forcing pilots to rely solely on modern GPS systems, which would also be compromised. This could lead to increased risks of navigation errors and potential accidents. Overall, the loss of the magnetic field would create a domino effect, severely disrupting technological systems that society heavily relies on, and necessitating a rapid adaptation to new methods of communication and navigation.
Our technology, which relies heavily on the magnetic field, would need to be completely revamped. We'd have to rethink the way we generate power, transmit information, and even travel. It would be a global crisis, requiring an unprecedented level of international cooperation to mitigate the damage. In the face of such a disaster, it's natural to wonder, could this really happen? The fact is, the Earth's magnetic field has weakened by about 5% over the past 100 years, and it's not uncommon for it to reverse poles every few 100,000 years. So while the chances of a sudden disappearance are low, it's not an impossibility. Dr. Andrew Z. Colvin, geophysicist at NASA's Jet Propulsion Laboratory, explains the effect of the magnetic field weakening.
The Earth's magnetic field has weakened by about 5% over the last century, and this has had noticeable effects on magnetic north. The weakening field means that magnetic north is shifting more rapidly than it has in the past. This shift can cause issues for navigation systems that rely on magnetic compasses, as the difference between magnetic north and true north, geographic north, becomes more pronounced. Additionally, the weakening field can lead to increased solar and cosmic radiation reaching Earth, which can affect satellite communications and other technologies. While these changes are gradual, they highlight the dynamic nature of Earth's magnetic field and the need for continuous monitoring and adaptation.
Imagine a scenario where the magnetic field vanishes suddenly, without warning. Chaos would erupt as the world struggles to comprehend the scale of the disaster. Governments would scramble to respond, scientists would race to find solutions, and the general public would be left reeling in shock. In the aftermath, we'd be forced to adapt to a new reality. We'd need to rebuild our infrastructure, our technology, and even our daily routines. It would be a time of great challenge, but also of great opportunity. As humanity struggles to cope with the loss of the magnetic field, we'd be forced to reevaluate our relationship with the planet. We'd need to become more resilient, more resourceful, and more cooperative. We'd have to find ways to thrive in a world without the protection of the magnetic field. In the end, the disappearance of the magnetic field would be a wake-up call, reminding us of our place in the universe and our responsibility to protect the planet. It would be a harsh lesson, but one that could ultimately lead to a more sustainable, more harmonious relationship between humans and the Earth. So, what's the takeaway from this thought experiment? The Earth's magnetic field is an often overlooked yet vital component of our planet's defense system. Let's appreciate its importance and continue to monitor its changes, lest we face a world without its protective shield. Thanks for watching. If you have any thoughts on what a world without a magnetic field would look like, leave them in the comments below. And if you have any topics you'd like to see covered in future videos, let us know.